semester. And again, we had said, let's see, let me minimize this, go up here. Test 4 will be due by the end of the day, Saturday. It should be available to you as of right now in my labs. The final exam will be due from the 3rd to the 5th. With both of these, they are in my math lab, but you must submit pictures of your work in Blackboard. Again, the final will be optional. If you do not take the final, I do not drop the lowest grade, test grade. If you do take the final, I will drop the lowest test grade. It's kind of like saying if you don't take the final exam was the grade that was dropped. Also, again, the last day for my math lab homework for you to try to complete things that were not completed will be on Sunday. Does anybody have questions about any of those? Not hearing any. Next in my math lab. Are there any questions that anybody has questions on? Anything from any of the homework or the, well, really, that's all we've got left in here. The homework that anybody wants to ask about. If not, are you folks ready? Oh, and I apologize. One more important thing to make note of. 5/3, which is Monday, will be the last day where I take attendance. So that 5/5, I'll be available in Zoom for questions. And if everybody's all right on 5/7, you know, if you need to get a hold of me, send an email and I can meet with you. Otherwise, you know, have a great summer. So that's the date wise. Is everybody all right with that schedule for next week?
Yeah.
Yes. Okay, great. Then let's go through. And I think on the agenda for today, all that I have today and Monday is to go over this practice final that I created. Again, this is going to be real similar to the questions that you see in my math lab. And oops, one last thing that I forgot to make note of. I don't think it pertains to anybody that's in class today, but if you do not have my lab's access, you need to email me ASAP. And in terms of submitting work in Blackboard, again, I would prefer it if you submitted it in Blackboard. It's easier to grade it that way. But if you have a problem with submission, email it to me. So, okay. So let's go back at, oh my heavens. Can everybody remember way back when we were looking at sets? I think the trickiest thing with sets is just remembering the notation. Otherwise, most of what we're asking is if something's in there or not. And so can anybody refresh my memory on what this symbol means?
Element.
Element, beautiful. And so I have to apologize. I'm just stopping to add William to the attendance. And so is 9 an element of this set?
Yes.
Yes, because it's in there. Beautiful. Next one, can anybody refresh my memory on what the cardinal number is? Do you remember it's how many things are in the set? How many elements are in the set? And so this one's kind of a three-part question. First, you have to remember what cardinal number is. Then let's look at this set. Can anybody tell me what days of the week begin with the letter N?
None of them.
None of them. So how many things are in that set?
0.
0. Beautiful. Next one says find the cardinal number for the set. And oh my heavens, does everybody remember this set builder notation? We read this as B is the set of all x such that x is a natural number, that uppercase N means that we're only working with natural numbers. And let's see, we've got 1 is less than or equal to x is less than or equal to 9. Does everybody remember? Because that equal sign is underneath, I will include the 1, pardon me. But I do not include the 9. So if I count, there's 1, 2, 3, 4, 5, 6, 7, 8 elements in that set. That one all right. If so, finite sets, we can count how many things are in there. Infinite sets, we can't count. They keep going on forever. So here, I'm looking at the natural numbers that are bigger than 1,000. If I go for all of the numbers bigger than 1,000, greater than or equal to 1,000, that would be like 1,000, 1,001, 1,002. And if I keep doing all the numbers bigger than 1,000, will I ever stop?
No.
No, so that's an infinite set. Now, next question deals with this symbol. Can anybody refresh my memory on what that means? Subset? It's kind of like, is everything from the first set contained in the second set? And by the way, it's okay if they're equal. So here, my first set is 5, that's in there. 7, that's in there. 9, that's in there. Since they're all in there, it is a subset. That one, all right.
Your numbers are different than the ones I have.
Oh, no.
Yeah, I noticed
This
that.
is different than the one that I printed up?
Yeah, because I don't know if everyone is on the same page, but question number 5 of yours is a little different, and so is question number 3.
Okay, well, what I'll do then is I thought I had only downloaded one copy of this. I'll start all over. And I will upload the one that's in Blackboard. I apologize. I did not realize that there were, I had created a second version.
I mean, on question number 3 was very mild. I mean, it was still the same numbers, just flipped around, but 5 is totally different.
Okay, I'll go back and upload the right one. I apologize for that.
No, it's okay.
Oh, it's taking its time. I'm sorry. Why is my internet so slow right now? Well, I'm talking about slow internet. Can I tell you guys an interesting story? The strangest thing happened in one of my classes yesterday. There was a young lady who said that after the start of class said, excuse me, I have to leave for a minute. My internet is not working. I keep getting booted out. My Wi-Fi is off. So I'm going to go to some place where I can use public Wi-Fi. And so she said she went to a park. And then, about 40 minutes, it was a 2-hour class. About 45 minutes later, she said, I'm sorry, I'm going to be making a little bit of noise, but I'm really nervous because I'm in a park and there's somebody parked right next to me, like right across from me. And they've just been sitting there for half an hour with their car running. And I think they're filming me. And so she was like very, very nervous about it. And so then, everybody was like, are you okay? Drive around a little bit, make sure they don't follow you. And she replied, oh no, I was just, I just moved my car and, I'm comfortable now. So, whatever. And so then we, continued with class. And then in the last 5 minutes of class, she said again, I'm sorry to be a bother, but I'm leaving class now. And I said, oh, why? And she said, because that car moved over and it's right next to me now. And another car pulled right in front of me and I'm really nervous. And I'm like, oh my heavens, what do you do? What can I do for her other than tell her to be safe? And but it was like the strangest thing. All right, now which was the first question that you said was significantly different, Marilyn?
Number 5.
Okay, so are you all right if we don't redo 1 through 4 and just pick
No,
up?
it was fine because even number, I think it was number 3.
Mhm.
It was the 8 was B and the 9 was C. That was the slight difference. But
Okay.
number 5 was totally different. The numbers were totally different.
Well, it's taking its time again. Okay, so I'm going to make this a little bit bigger. So this one was true. This one was nothing. The cardinal number for this set was 8. This one was infinite. 2, 4, and 6 are all in there, so it's a subset. Is that better?
Mhm.
Okay. Then question number 6.
What was number 5? Remember, it was different than ours.
Number 5, what I've got is 2, 4, 6, a subset of 1, 2, 3, 4, 6.
Okay.
Is that what your question
Yep.
is? Okay.
Ready?
Then question number 6, we're asked to find how many subsets and how many proper subsets there are. First of all, we want to find the cardinality of that set. How many things are in there? And so there's 1, 2, 3, 4, 5, 6 elements. And so do you remember the number of subsets was 2 to that power? And 2 to the 6th is 64. And for the number of proper subsets, it was 1 less, or 63. That one okay?
Yes.
Next one then, what we have to remember is 2 things. This is the intersection, which just like when 2 roads intersect, that means it's the overlap. And this is the empty set. So we could write over here one more set that says the empty set doesn't have anything in here. So now if I compare C to this set, is there any overlap? Is there anything that they have in common? No, so the intersection is the empty set. Next one's similar but different, because here, again, we're taking the intersection, but we're taking the intersection of A and B. So what do they have in common? Let's see, they both have Q, they both have S, and they both have Y. And so that would be their intersection, what they have in common. Does everybody remember taking the intersection of two sets? Next one asks for A prime or A apostrophe. Remember that was the complement. And the complement meant everything outside the set. And so if A contains Q, let's take the Q out. Let's take the S out of our universe. Let's take the U out of our universe. Let's take the W out of our universe. Let's take the Y out of the universe. And when we take those out, what's left is the R, the T, the V, the X, and the Z. And so I believe that's choice C. Does everybody remember the complement of the set? Everything that's in the universe, but not in the set. Can we go on to the next one? Question 10. Instead of giving us a roster, they give us a Venn diagram. And does everybody remember U is the union? And when I take the union of two sets, I just combine them. It's all of the elements from either set. So in and I'm actually not looking for the union, but rather the cardinality. And so initially I was going to list them, but I hope you don't mind, I'm going to get a little bit lazy. When we take everything that's in A and combine it with everything that's in B, including the overlap, is everybody all right? It would be all of the elements in that region that I just highlighted in red. So if I were to count, there's 1, 2, 3, 4, 5, 6 things in there. So the cardinality of that is 6. So just a few questions to have you rethink about all of that we did with sets. Next question says, an ice cream store sells 5 drinks in 4 sizes and 7 flavors. And you remember, counting principle tells us the number of ways that I can, number of choices I have between the 3. Counting principle told us to multiply. So that's 20 times 7 or 140. And so there's 140 ways that a drink can be ordered. Next one, similar yet different. Here, license plates in a state contain 3 letters followed by 3 numbers. How many state license plates can be manufactured? Well, for the first letter, there are 26 choices. Nothing tells me they can't repeat. And so for each of the letters, I have 26 choices. And then remember, for each of the numbers, I would have 10 choices because I'm including 0. And so my answer, using the counting principle, would be the product of those 26s. Or with my calculator, I'm going to take 26 to the 3rd and then multiply it by the product of all those 10s, which would be 10 to the 3rd. And so there are 1756000, or 1,750,000 756,000 different license plates. Next question is also counting. It says how many ways. So I know my answer is going to be a whole number. We want there are 9 cars, and we want how many ways the first 3 can finish. In a race, does order matter?
Yes, it does.
Yeah. Otherwise, why are you running a race? You always want to see who comes in first, second, and third. And so since order matters, does everybody remember that's a permutation? There are 9 and we want 3. And so you can use your calculator to evaluate that. Does everybody remember your permutations are under that PRB menu? If you've got a graphing calculator, you've got to look a little bit further. 9 permutation 3 would be 504. If you don't have that permutation key, remember 9 permutation 3. The 3 tells me I'm taking 3 factors. The 9 tells me I'm starting with 9. So that would be 9 times 8 times 7. And so 72 times 7 would be 504. Next question talks about committees. And does everybody, well, first of all, how many? So we're getting a whole number. Committees, does everybody remember we said with committees, order does not matter. And if order does not matter, it's a combination. I see that word and in there, so I think I'm going to be multiplying 2 of them. First, for the men, there are 10, and I want 2. Then for the women, there are 6, and I want 2. So using your calculator, 10 combination 2 would give you 45. Using your calculator, 6 combination 2 would give me 15. And so when I take 45 times 15, I get 675. Could somebody just check, make sure I got those combinations right? Because I was kind of doing them in my head. Everybody all right with that one?
Yes.
Next question asks for a probability. And so remember, for probability, my answer is going to be a fraction. This, I think, was one of those earlier on probability questions. I have a deck of 52 cards, so I could get any one of the 52s. I want to get a 10. What you need to remember is in a deck of cards, there's the 10 of hearts, the 10 of diamonds, the 10 of clubs, and the 10 of spades. And so there are 4 10s. So I will accept it if you put in 4 over 52. My labs won't. They ask you to reduce it to 1/13. That one all right? If so, next one, we've got a single die being rolled twice. Remember, the first die has 6 outcomes, the second die has 6 outcomes. So we get 36 outcomes altogether, and they would be the number pairs here. Find the probability, so our answer is going to be a fraction, or our answer has to be something between 0 and 1, of getting a total bigger than 18. As I look at this one, does everybody see that the largest sum is a 12? So again, I get a number bigger than 18. It's not possible, so the probability is 0. Remember that the probability of an event equals 0 if the event is not possible. And I have to apologize. I haven't been asking often enough. Are you folks remembering this stuff? Am I going at an all right pace? Please yell at me to stop if you need more details or more of a gentle nudge to your memories. Are we doing all right so far?
Yeah.
Thank you. Then next page. It says a group consists of 7 men and 6 women. They're being selected to attend a conference. Okay, if they're going to a conference together, since they're going together, we're going to say that order does not matter. If I went to a conference with you, it would be no difference than you going to a conference with me. So order does not matter. And so does everybody remember that tells me I'm going to use a combination? For part A, we want to pick 3 from the 13. So that's going to just be 13 combination 3. And 13 combination 3 is 143 times 2. Is that 286? Why am I trying to do this without a calculator, guys? Yeah. Do you ever have a day where you keep typing things in wrong? 13 combination 3. Yeah, it's 286. Why did I doubt myself? Next one asks for a number of things. And so this time we want 3 women from the group of 6. So that would be 6 combination 3, which is, I believe, 20. Can somebody double check that for me? And so the probability that all 3 are women, well, that would be the number of ways that I can get 3 women, which we found already, over the number of ways I can get 3 people. And that fraction looks reducible to me because they're all even numbers. Dividing out 2, I get 10 over 143. And so that would be my final answer.
Professor, I have a question.
Sure.
I'm sorry, I don't know if you already talked about this, but I just was wondering how many questions are on test 4.
I believe, going on memory, that test 4 has about 16 questions.
Okay, thank you.
Some of them have several parts, though. It's very similar to that practice test that we went over on Wednesday.
Sounds good. Thank you so much.
All right, you're welcome. Next question asks about odds. In order to find the odds in the favor of getting a heart, remember we have to find the probability of getting a heart. And then we also have to find the probability of not getting a heart. So I'm crossing that out. That means not a heart. Is everybody all right? The probability of a heart. Hearts are a quarter of the deck. And so not a heart, that would be 3/4. Can I jump to those reduced fractions without losing anybody? So the odds in favor of a heart, well, that would be the probability of a heart to the probability of not a heart. which would be 1/4 to 3/4. But we want to make sure that those fractions that we write have common denominators. And so we can just take the ratio of the numerators. So the odds would be 1 to 3. Does everybody remember odds, that we have to find the probability of it occurring? But the odds is not just the probability. We also have to find the probability of it not occurring and then take the ratio of the two. Can we go on to 19? "19 is an example of that conditional probability. And the condition that we have is that we know we're selecting a green one. Also, we want to make sure, because we're looking for a probability, that our answer is a fraction. So we only want to look at the green ones. So we're pretending the blue ones aren't there. If we're only looking at the green ones, does everybody see there are 5 discs? Of those 5, only one has the number 3. So that probability is 1/5. So again, a sampling of questions on probability. Next question is from the study of statistics that we did. It asks us to make a frequency distribution. So everybody remember, frequency distributions sound fancy, but they really aren't. All we need to do is count how many numbers there are of each. So I'm going to go through and make a tally. 20, 23, 24, 21. Yep, I got another 20. 19, 17, 16, 24, 18, 23, 16, 17, 25, 22, 21, 24, 19, 18, 19, 22, 25, 17, 20, 20, 19, 16, 18, 17, and 25. And so I have no 15s, 3 16s, 4 17s, 3 18s, 4 19s, 4 20s, 2 21s, 2 22s, 2 23s, 3 24s, and 3 25s. I have a tendency when I do these to cross the numbers out, because otherwise I start going cross-eyed and can't remember if I counted something or not. But how's everybody with their frequency distribution? I remember folks thinking frequency distribution sounds so complicated. Really, all we're doing is counting how many we have of each value. Are we good?
Yes.
Okay. Then the next thing, what we've got is on a pencil and paper test, I'd be asking you to draw these, but the way my labs does it is they ask you to pick multiple choice. So it says a random sample of 33 male college students is selected. Each student is asked his height to the nearest inch. The heights are shown in the frequency distribution below. Construct a histogram and a frequency polygon for the data. Does everybody remember histogram is a bar graph where the bars touch along the horizontal axis? I have to have my data values. Along the vertical axis, I have to have my frequency. And so we're starting with 2 people being 66. Well, this doesn't show anybody being 66. This one shows 4 people being 66. This one shows 6 people being 66. So I'm thinking it's this. Let's check. 266, 367, 168, 269, 370, 671, 472. I think we've got our answer. And then once we have our histogram, the frequency distribution, the frequency polygon is very much the same thing, except instead of having bars, the frequency polygon would be as if I put a dot in the middle of each of the bars and played dot to dot. And so the frequency polygons shape to look very similar to that of my histogram. And so again, at 66, I have 2, at 67, I have 3, and so on. So here, the frequency polygon would also be D. Is everybody all right picking those 2 graphs out? Next then asks us to find a mean. Oh dear. How do I find the mean? So remember, we total the numbers and divide by how many?
By 8.
So there's 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. And what do those add up to? 9, 10, 11, 15, 23, 29, 30, 31, 32, 38, and 9 is 47. Does somebody want to check my addition and make sure you get 47? 9 plus 2 plus 4 plus 8 plus 6 plus 3 plus 6 plus 9. Yep. And so when we take that 47 and divide by 8, I get 5.875. I would use the rounding rule, but over here, they don't tell you to round, so let's keep all of that. Rule of thumb, only round if they tell you. And that's one measure of the center. Another measure of the center is the median. And you guys remember, for the median, the first thing that we want to do is order the numbers. They must be in order first. So the smallest is 12. Then we have a 13. Then we have 2 14s. Then we have 15, a 16, an 18, and a 19. And I double check 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So the middle of the list would be, to be in the middle, it would have 4 on each side. There isn't a distinct number in the middle, so I take halfway between those two, or the average of those two, which would give me 14.5. How's that one? Any questions? If not, I'm going to move on to the next page. Next one asks us to find the mode. And does everybody remember the mode is a value that happens most often? It's also the value that has the highest frequency. So first I'm going to look at these frequencies. And I think the highest frequency is 7. And since the highest frequency is 7, our mode will be the number that has that frequency of 7 or 7. Everybody all right with that one? So I'm going to make this a little bit bigger so I can write a little bit more on it. Standard deviation. And again, before I put the, I will put the, actually, you know what? No, I'm not going to put another formula sheet in there. We had a formula sheet for the statistics test, and we had a formula sheet for the consumer math test. Please make sure you have a copy of both of those available for the final. Remember, for the standard deviation, we said we were going to take each value and subtract the mean, square those differences, add them up, divide by 1 less than the number of values, and take the square root. In order to do this, I find it easiest if I make a table. So first column, I'll put in my numbers, 19, 20, 21, 21, 22, 23. And so when I add those up, 10, 11, 12, 13, 14, 15, 16, 2, 4, 6, 8, 10, 12. So that's 126. There's 1, 2, 3, 4, 5, 6 numbers. So my mean is 126 divided by 6, which is 21. And then remember, we subtracted the mean from each of those values. And after we subtract it, we took that number and squared it. So 19 minus 21 is -2. And remember, we're squaring them to make it positive. So that last column should be all positive. 20 minus 21 is -1, squared is +1. 21 minus 21 is 0, squared is 0. 22 minus 21 is 1, squared is 1. 23 minus 21 is 2, squared is 4. Well, we don't have to add this third column. If we do, it should add to 0 unless we hit a round off of the mean. Now we're going to add this next column, which gives me 10. To find that standard deviation, we're going to take that 10, and first over here we divide it by 6. So we're going to divide by the number 1 less, which is 5. So that gives me 2. And then to take the standard deviation, I'm going to take the square root of 2, which gives me, I believe, 1.41 to the nearest 2 decimal places. Does everybody remember doing that standard deviation?
Yes.
Next one then says that the mean is 140 and the standard deviation is 28. We're asking for the score that's half a standard deviation above the mean. If it's above the mean, does it make sense that it's bigger than the mean and I have to add? And I'm not going to add the whole standard deviation, but I'm just going to add half of it. So the mean is 140, and to that I'm going to add half of 28. And so 140, pardon me, plus 14 would give me 154. Everybody all right with that one? Next question says, not everybody pays the same price for the same model of a car. The figure illustrates a normal distribution for the prices paid for a particular model of the new car. The mean is 21,000. So does everybody remember that that means the middle number is 21. The standard deviation is 2,000. And so I'm going to count by twos away from 21 on either side. We're asked to use the 68, 95, 99.7 rule, which again tells me that 68% of the data will be between these two values. 95% of the data will be between these two values, and 99.7% of the value will be between these two values. If I want to find the percent that paid between 17,000 and 25,000, see, 17,000 is here, 25,000 is here. As I go up, those are actually the boundaries for 95%. And I'm just looking at the clock, and we only have 2 minutes left. So let's stop here, and we'll finish going over this on Monday. You might want to try, after you finish test 4, looking at the rest of this on your own on Monday. And if you're interested, because I messed up, this second copy, which is going to be very similar, just with different numbers, will be attached to today's notes in Blackboard if you want to try going over another one. And we will do as much of that as we can on Monday, and I will fill in the rest of the answers to that one after class Monday so that you can check yourself. So, how's it looking? What are you folks thinking at this stage of the game? Do you think you're going to try that final, or do you think you're going to skip it? Looking at it, do you remember all this stuff? In retrospect, looking back, do you guys feel like you learned very much this semester?
Yeah, it's all coming back again.
Mhm.
Okay.
Can
All
I
right.
give
Well,
can I give my opinion to the class and you?
sure.
Looks like I feel like the final looks easier than the fourth exam, but that's just me.
Well, take the fourth exam and you'll find that I think the final, I tried to take the same number of questions from each of the tests. And so the last quarter of the final will be questions from that exam 4. So take that exam 4 and then look at the rest of the final and see what you decide. If you're, there's no, I guess, penalty in taking the final. If you take it, it won't necessarily, it couldn't lower your grade because it would be, if it was your lowest grade, your dropped grade. However, if going into the final, you've got a grade that you're perfectly happy with and you don't want to stress over another test, don't feel obliged to take it. And then flip side, if you missed a test or you bombed a test, then definitely take that final and it'll replace that missing or lowest grade. Okay.
Yeah.
And hopefully, because everybody's going to get their test 4 done by Saturday night, hopefully I've got 4 classes having test 4s done by Saturday night. Hopefully on Sunday, I'll get all of them graded. And then you can look in Blackboard and see what you think. After that point, the only thing that might change in your Blackboard grade is your MyLabs grade, because again, if there's anybody who has a lot of undone homework, your MyLabs average is going to drop. So try to get those My Lambs done by Sunday. Other than that, I guess let's stop recording.